So the final piece of the puzzle today for this case study, for the PrimeCheck app case study, is to look at the test driver implementation, and we'll also run everything and see how it performs. So you can see that this is where it all comes together on the client side. This is the driver that invokes all the operations with the different strategies on the server. And you can get the code here in the EX1 project, in my web MVC folder, in my live lessons GitHub repository. Here we are back in that project. And now we're going to take a look at the test program. And as you can see here, this has got a couple things that makes it a test program. It's got a Spring Boot test annotation on it, and it says which server application to launch. There's a little restriction with Spring. You can really only launch one server, so this kind of test works fine, sort of on a microservice by microservice basis. Doesn't work try to do an integration test per se. You have to do other things. You can see that we are going to define the port number here for this, and that's actually defined over here in the resources portion where it says that's the port number. So we then define ourselves a bunch of different client proxy objects, one for each different type of strategy. We have one for parallel streams, one for structured concurrency, one for the vanilla CompletableFutures strategy, and one for the one that's the version that uses the virtual threads. And these are all slightly different, which is why we can't completely factor out that logic. So each of these things works in a slightly different way. So we have to have separate classes for each one. We then go ahead and define some command line arguments. We're going to test 50 large random integer objects. We're going to disable debugging by default. And then we have the run tests test method. You can tell it's a test method because we put the test annotation on it. That's going to print some diagnostics, parse the arguments. We're then going to generate a large number of large random integers, and we can control how many and the size through the parameters we get from the options singleton. And then we go ahead and we test each of these different client proxies. So we got 4 proxies. We got 4 calls to a helper method called test. We pass in the test method to run, the random integers, whether we want to run things in parallel or sequentially, and then we print out, or we pass in the name of the test so we can see at a glance which test ran. And you can see we're doing essentially a bunch of calls with either client-side or server-side parallelism enabled or disabled. So we got a whole bunch of different calls here. Lots of calls, as you can see. They're all using this time test helper method, which takes in a by function, which is going to take the list of integers, a Boolean, and the results. And this is the test method that we're calling, whether we're running in parallel or not. In the name, we start out by garbage collecting everything just so that each test starts with all the memory that's available on the system. And then we're going to go ahead and apply the operation passing in the prime candidates and whether we're running in parallel or not. That's going to return a list of results, and then we're going to display the results when we're done. And this is timed using my little run timer time run helper method. I do this a lot for most of my examples, and you can see what it does is it takes a snapshot of the current time of day in nanoseconds, invokes whatever parameter we pass to it using the supplier get method, get the result back, stop the timer so we know how long it took to run, and then we store the results into the results map. And you can see here that we probably want to make this something that's final. There we go. So that just records all the results, and then when we're done, we're going to print the results out. I won't go through this code right now, but it's a nice way of being able to print all the results. So that's what the tests do. Let's run the test now, and let's see what happens when we do that. So we right-click, and we're going to run the test. And what that does under the hood is it hopefully compiles everything. Hopefully everything compiles. And then once it's compiled, it'll start by calling the test annotation. There was a method that did the annotation for the test. And that will then call each of those different proxies, passing in either true or false as to whether we're running concurrently or not. And now you can see the test is up and running. The server side has started up. And here's the client side. You can see the diagnostic messages coming through here. And let's take a look for fun and see how things did. So everybody went off and ran with a count of 50. And then you can see here, these are the results that we got, which is kind of fun to take a look at. So as you can see, we had 16 results with things running in parallel or sequentially on either the client and or the server. And you can see here that the version that did the list version, which is what you'd expect, it ran the best. So that was the one that passed over a list to the server side, and the parallel streams version executed very, very quickly. You can see that the completable future list version also went pretty fast. The sequential version of completable future also went pretty fast. So you can see that the list versions are the ones that are winning in general because they're doing all the computation on the server, and there's less back and forth where you're sending each request separately. You can see all the individual calls were substantially slower than the parallel calls, which is, again, what you'd expect if you think about it. And some of the stuff takes a lot longer to run than when we're doing things with some of the real super fast versions.